friends and fans of OSG. Welcome back to our YouTube channel. My name's Alyssa Walther and I'm a product engineer with OSG USA. And today I'm excited to continue our discussion about OSG's A-brand AE-NIC series. And today specifically we're going to talk about the AE-VML and the AE-NIC-VML, which is OSG's long length of cut end mill for high efficiency machining, or trochoidal style milling, sometimes it's called. I'm going to hit you guys right away with a demo on the machine for the AE-VML tool. But before I get to that, just real quick, if you haven't already, please click on that red subscribe button and subscribe to OSG USA's YouTube channel. You can also follow us on LinkedIn, YouTube, and Instagram. And if at any point during this segment you have any questions or comments that you'd like to send on over to us, put it in the comments box and send it over to us. And at the end of this segment, I'm going to try and answer any and all the questions that you guys have for me today. So without further ado, let's go over to the machine. We're going to look at the AE-VML tool in a block of 1045 carbon steel doing some high efficiency machining in a pocketing sequence. Let's check it out. All right, for those of you just tuning in and you just saw that video, what you were watching was the OSG A-brand AE-VML long length of cut tool designed specifically for high efficiency or trochoidal style milling. So what you guys saw there was the AE-VML doing a pocket. It dropped down 3 times D length of cut, so 3 times the diameter. This was a 12 millimeter tool. It did a little bit of trochoidal milling to open up the pocket, and then it picked out the corners. So trochoidal milling, what is that? High efficiency milling. Well, it's basically a newer method of removing material with an end mill, okay? There are many different ways to program toolpath cycles. This is a newer way to do it. And if it works for your application, that's great. Trochoidal style milling is more characterized by deep depths of cut. So when I talk about deep depths of cut, I'm talking about 2.5, 3, 3.5, 4, and more times the diameter as far as axial depth of cut goes, coupled with a more conservative light radial step over. So here I'm talking about 5%, 10%, 15% step over. But because we're doing such a light step over, we need to make sure that the productivity isn't slacking behind. So typically speaking, high efficiency milling typically comes with higher table feeds as well. Now, this particular example with the VML was doing 86 inches a minute at 3,500 RPM. Again, this is a 12 millimeter tool. Now, in addition to being a trochoidal style tool path, we did this in a pocket. So let's talk about pocketing real quick. Unless it's a circular pocket, If it's a square type pocket, you've got some straight walls that you're going to be cutting, and then you've got to cut some corners too. Now, one of the reasons that people turn towards trochoidal style milling is kind of because it's got a factor of safety built in. Now, the tool path, when you use high efficiency machining, the tool path tries to make it so that every single time the end mill touches the material, it's taking the exact same amount of material from top to bottom, okay? So that means that there's less likelihood that during the tool path cycle, it's not going to jam itself into a corner and squawk and squeak or break in the worst case scenario. So trochoidal milling is nice if it works for your application, and it's also safe, and it gives you longer tool life. Now, in the case of pockets, though, you have to turn a corner, regardless if you're trochoidal milling or doing Z-level roughing or what have you. You have to turn a corner. So at some point, that end mill is going to reach the corner and then turn. And when it does that, that's the problem area in most pocketing applications, because it goes from having hardly any engagement along the wall to suddenly being trapped into a corner. So that's where you hear the squeaking, the squawking, you see the chatter on the corner edge of the pocket. Now, with the AE-VML that you guys just watched now, you didn't hear or see any of that. The AE-VML did exactly what it was supposed to do because it's designed to be able to handle chatter and vibration with regards to long and deep depths of cut and high efficiency machining passes. Now, can you take any old end mill that has the length of cut that you need, drop it down into a pocket, and expect it to perform the exact same way as this AE-VML did? Let's check out a conventional tool trying to do the exact same thing. Let's go. All right, so what you guys saw was a condensed little clip of a conventional tool trying to do that exact same pocket that the AE-VML did. And the sound was okay. There was a little bit of chatter, especially if you heard it in the corners, where I said is the trouble spots to begin with. What I didn't tell you is how much we had to turn down the speed and the feed for that tool just to get it to sound that way. Okay, so for reference, we went from 3,500 RPM with the VML tool down to 1,200 RPM, 1,120 RPM. Okay, we had to reduce the speed because there was so much chatter, and then we had to reduce the feed rate too. We went from 86 inches a minute down to 25, so we're not even getting a third of the productivity with this conventional tool using high efficiency machining passes as we are with the AE-VML. So what does that mean to you? If you're serious about high efficiency milling, you really should be serious about having a tool that is designed for high efficiency milling. Plain and simple, you're not going to get the productivity that you're looking for if you just buy a run-of-the-mill, no pun intended, end mill with the length of cut and think that it's just going to be okay. So, moral of the story, the AE-VML is designed for the high efficiency machining passes. Now, there was one little thing with both of those tools. I'm not sure if anybody caught it, but it was right at the beginning. And it has nothing to do with the fact that it was trochoidal milling or high efficiency milling. It had to do with the fact that the pocket was so small in the beginning. So if you noticed, we pre-drilled some holes in the middle of these pockets and dropped the end mill right down into it, which is a common practice, okay? It's nothing different than what a lot of people are doing. But the problem is, if the drill hole is similar in size to the end mill, and the end mill drops down in that hole, you're going to run into chip evacuation problems because of the depth of cut. Now, I said before, the depth of cut on this tool for this demo was 3 times the diameter, so 36 millimeters. That means that the chip that came off of the VML is 36 millimeters long, and it's got a hole this big to get it up out of, right? That's going to cause some chip packing, some recutting of chips, which essentially leads to chipping of the tool, or in worst case scenario, breakage of the tool. And it's like failing at the start line instead of even the finish line, and nobody wants to be that guy, right? So for the VMLs, the AE-VMLs, they work fantastic for high efficiency milling, but you have to be concerned with the starting size of the hole. So it's not that great because of chip evacuations, issues, when the size of the pocket is small. Medium to large size is no problem, and you'll get amazing finishes from it. Now, our answer to the smaller size chip evacuation problems is the AE-NIC-VML. Now, what is that? The AE-NIC-VML is the VML tool, basically, with some serrations in the outside diameter of the cutting edge. So what that does is it takes that big old long chip, that 36 millimeter long chip, and divides it and separates it into more manageable, smaller pieces so that when it first drops into the hole, those chips are already broken up as soon as the end mill hits the material. And then those chips just start flushing out of the hole, no problem, no issues with recutting, and it just hums along. So don't take my word for it. Let's take a look at the AE-NIC-VML tool in that same pocket. All right, so hopefully you guys saw exactly what I was talking about. As soon as the end mill, the NIC-VML, dropped into that pre-drilled hole and made contact with the material, chips were small enough and light enough to be able to just be pushed right up and out of the hole. It hummed along the rest of the pocket, no problem. So that's really it in a nutshell. The AE-VML and the AE-NIC-VML. When to use either tool? Well, with the VML, you're going to get amazing finishes. It's going to be great for medium to large size pockets. The NIC-VML is more of a semi-roughing and roughing tool, but it's going to give you great performance in those smaller pockets for when you need to really, really get chips out of the pocket. So that being said, I'm going to take it to the queue here and see what kind of questions you guys have of me and try to get some answers for you. So what have we got? And maybe while you guys are thinking about it, I'll just tell you guys a little bit about the offering size. So the AE-VML and the NIC-VML are identical offering sizes. We've got inch and metrics. We've got millimeter, 6 millimeter up to 12 millimeter, and 1/4 inch up to 1/2 inch. And as far as lengths of cut go, we have 3 times D, and then we also have 4 times D. So that's the offering size. And as far as materials go, the bread and butter of these tools are going to be your alloy, your carbon steels, and your stainless steels, and your cast irons as well. Secondarily, you can also apply these tools into anything up to 45 Rockwell aluminum, your wrought and your cast aluminum styles, titaniums, as well as some nickel alloys as well. Anything from the line yet? All right, well, last little bit here, just to give you guys a reference, what we were doing on the machine here was 1045 carbon steel. We're doing about 430 surface foot, so 3,500 inches a minute, or I'm sorry, inches a minute, RPMs with a 12 millimeter tool doing 86 inches per minute. That was 3 times the depth of cut with a 10% step over, just to give you guys a reference. In our catalog, we do give recommendations depending on what step over you want to use, 5%, 10%, 15%, and then the numbers will be adjusted accordingly. So it doesn't look like there are any questions at this point, but if you do have any questions, please don't hesitate to reach out to OSG. We love to hear from our customers. There's a couple ways you can do that. There's a number scrolling across the screen, hopefully, with our 1-800 number. You call that number, and it'll get you in touch with our customer service department, our inside technical department, and if you request it, the engineering department as well. There's another way you can go. Go to our website at osgtool.com. On a website, it'll be a button where you can click. It says Virtual Engineering Visit. Click on that, and it'll give you the option to take 30 minutes or a 60-minute consultation with any member of the engineering department. We got a question.
A couple of questions coming over our chat line. The first one, how would you compare the surface finish with the AE-VML compared to the conventional end mill that we saw?
Okay, definitely. So maybe you didn't catch it right after we showed that the clip, but the chatter was the deciding factor on the finish there. So with the conventional tool, you saw, especially in the corner, actually I think if I remember correctly, there was chatter along all of the straight wall as well, but even more so in the corner where it turned. That was the main factor. It was kind of, because we tuned it down so much, we tuned it down like 50% on the speed and had it at 30% of what the VML did on the feed. So the chatter amount wasn't so significant, but if you zoomed in on it, what chatter looks like is kind of like diagonal diagonal like lines, which is an indicator from on the part that your tool was chattering. So the VML didn't have any sort of diagonal type lines. It was very shiny, very smooth. The only thing, and speaking of finishes, the only thing I want to say here is the difference between the VML and the NIC-VML. Because the NIC-VML has those serrations in the OD, you aren't going to get as good of a surface finish as you will with the straight edge VML. So that's a little bit of a difference in the geometry of those tools as well.
We have another question asking to explain a little bit more about the coding that we use on the AE-VMLs.
Dual-Rise. So the Dual-Rise coating is one of the newest milling grade coatings that OSG has come out with. It was brought in at the beginning of, I believe it was IMTS last year, when we introduced the A-Mill series, basically. But the Dual-Rise coating is one of our hardest coating. It's not the hardest milling grade coating that we have currently, but it's let's say top 3, okay? So it's very hard and very lubricative, so which makes this tool, or this coating, I'm sorry, a very ideal coating for those gummier type materials, which is why I said the AE-VML series is going to be great for those gummier stainless steels like your 304. It's going to work great for your steels under 35 Rockwell and some of the gummier stuff as well. So it's got a good slipperiness to the surface of it. Talking about the Dual-Rise coating. All right. Well, thank you guys so much for those questions. I really appreciate that. So I told you guys about how to get in contact with us if you have any more questions. And I think I can. One last thing. As a thank you for being here with me today, OSG wants to send you this free Bring Your A Game hat. How do you get this hat? In the comments box right now, type in A brand, A game. That's A brand, A game, if you want to get this free hat sent to you, and a member of our marketing department is going to reply to your comment to get more information on how we can get this out to you. So again, thank you guys so much for being here. This was the AE-VML series, and if you are a customer that does finishing, wall finishing, I suggest you tune in on July 30th at 11 o'clock a.m. Central Time. We're going to talk about the AE-VML specific to one-shot finishing, wall finishing passes. All right? Looking forward to seeing you guys then. Till then, you guys take care.